Hi guys, long time no see. I got my interest back on Magic of Reality and we're going to do chapter 9 review today. And I will continue the book until I'm done. So this chapter is about aliens. Are there really other lives on planets? Or are we alone? So to start off, there are really no myths about alien life. It's more of modern stories. One of the modern stories is Heaven Gate cult. This cult had 39 members who, at that time, thought a comet that was coming by, had a spaceship in it. And they got a telescope to investigate, and there was no spaceship in it. And so they thought the telescope was broken because the comet wasn't showing the spaceship. So all 39 members committed suicide. Sad. So many people have stories like this, like someone thought aliens were doing nasty experiments to them. So one of the common reasons this happens is because of sleep paralysis. Sleep paralysis is when you're sort of awake or conscious and you can feel or know the surroundings around you, but you're paralyzed or your muscles won't move. And at these times, there are terrible hallucinations or dreams. So that's pretty much closing up the stories. Are there any alien life on other planets? Well, before we need to know that if there are alien lives on other planets, we need to know that are there planets orbiting around a star? There are different types of methods to find out if a planet is orbiting around another star. One of the methods is where, before learning this method, you need to know about this. So when two planets or two massive objects have same size and same mass, they'll exert the same gravity on each other. So they'll go around like a dumbbell like this. They'll go around each other like a dumbbell. But for example, one of them is bigger and the other one is smaller. The bigger one will exert more gravity onto the smaller one. So the smaller one will rotate or orbit around the bigger one, like this. So this is the bigger one, the smaller one will orbit like this. But the smaller one has a little teensy effect on the bigger one. And the bigger one will slightly move, like this. So this is the smaller one and the bigger one. So this is where the spectroscope comes in. The spectroscope is something that detects light. And when the star is sending the light, the people using the spectroscope can detect the red shift, blue shift, like that. That is how many astronomers found exoplanets. Another method is eclipsing. Let's say a planet is the planet has to be perfectly aligned with the starlight. This is the sun, or star, this is the planet. It has to be like this. This is when an eclipse happens. It also happens with the moon and the sun. So they found 500 plus planets using these types of methods. And in our galaxy, there are 100 billion stars. And in the universe, there are 100 billion galaxies. So that can conclude that there are probably a lot of planets orbiting around stars. Well, the likeliness of having a planet orbiting around a star is pretty high because all of the stars, or most of the stars we've discovered, had planets orbiting around them. So now, let's say we found some planets around the star. Do all planets have life on them? Actually, no. Some of the stars are much bigger, so they will burn faster, thus having no life. Only 10% of the stars we've discovered are sun-like, so the smaller ones won't provide enough sunlight and the bigger ones will burn up too fast. Also, they would need to be in something called a Goldilocks zone, which is right temperature. It cannot be too hot or too cold. So when you're in the Goldilocks temperature, It's just right for plants to have sufficient light to grow. Also, water is very essential for people. For life. Water is very essential. And if you're in the Goldilocks zone, the right temperature will give you a high chance of having water. So most of the planets we've discovered are actually something called a Jupiter. It's a gassy giant. So the planets that we've discovered orbiting around stars may not have life. So size also matters with planets to have life. So for example, let's say a planet that's the same size and diameter as Earth is like full with pure gold. It would be 3 times as heavy as the Earth, which makes it have more gravitational pull. So if life needs to be living on that, natural selection needs to make sure that life has thick bones so it can walk easier with the gravitational pull. And due to gravity, natural selection will do its thing. Same thing with coal. Coal is much lighter than gold, so the gravitational pull would be less than what it is on Earth. So gravity and natural selection would make the bones or layering be thin. So let's say that we have found planets that have aliens. How would they look like? So to start off, life needs water, temperature, and size. We also need to know that when light from the star is shining on the planet, or light is coming on the planet, it'll show around the surroundings. But for that, we need eyes. Eyes are very critical because with the eyes, we can look around for our surroundings. We can know what our surroundings are. Like, for example, with light, we can see a chair or TV or something like that. There are different types of eyes. So, to start off, there is a camera eye. A camera eye has a small lens where light goes through that lens. And at the back of the camera, there's something called a retina. That is where the image that the light is sending through the lens will go through. And the retina will have the image. It's pretty much the same thing with the human eye. The human eye has a lens and a retina. So when light goes through the lens to the retina sends it to the brain. The brain will make a useful image out of it. The difference between a camera eye and a human eye is a camera eye zooms in and out like this. And a human eye uses its muscles to contract and expand. Expand, contract, expand, contract, like that. Another type of eye is a jumping spider eye. This eye has a lens and light goes through the lens, but instead of having a wide retina like the camera eye and the human eye, it has a narrow strip retina, this small. And it'll scan scene by scene, like this. See? Like that. So it'll scan like that. So the next eye is something called a compound eye. This eye, rather having a lens, has lots of tubes. And with the tubes, the light goes through the tubes, right? So those tubes, let's say for example a dragonfly, which has a compound eye, the light goes through the tubes. And the dragonfly will only focus on the important parts of the light. Like for example, the light is showing the prey. It'll focus on that part only and jump for its prey. The last type of eye is the curved mirror eye, something a scallop uses. A scallop is like a clam type fish. It's like a clam. So a scallop has a curved mirror eye, so it uses a mirror, and instead of the retina being in the back of the eye, it's in the front. So large telescopes also use this method. So the mirror light goes onto the mirror, and the mirror reflects it to the retina. And so that's that type of eye. So if we open up our imagination to see like what aliens could have evolved to, we could understand that there could be an eye like infrared eye, ultraviolet, X-ray, or radar, or radio, something like that. So a radio wave eye would be very, very bad because, first of all, to know, you have to know this. To get a good image, you need very high resolution. A radio eye has very long frequency, or radio waves have very long frequency. So having an eye for like that type of frequency would be very bad for resolution. But opposite, X-ray eyes, they have short frequency, so it would make good resolution. There are also infrared and ultraviolet, colors us humans cannot see. So those could also be an eye aliens could have adapted. And also, if the planet, for example, is like filled with thick fog, eyes would be useless. So there's something called sonar, where bats, whales, dolphins, submarines, they use something called sonar. Bats use it because they have poor eyesight, and so they use sonar. It's like an echo of sound, and they'll hear like what's around them, like a cave or like a tree or food or something like that. So I said that radio wave eyes are very bad for eyes. They're like bad for eyes, but they're really good for communication, like radars. They're good for communicating with one another. Another type is what fishes have. They have something called an electrical sensor. This way is called electrical sensitivity, where alien life could have adapted to. So electrical sensitivity is when the fish is moving in the water, right? So the prey of the fish uses its muscles to go through the water. Those muscles will give it'll trigger the electrical sensor of the fish, and the fish will know where its prey is because of the electrical sensitivity. So those are pretty much all the types of like ways alien life could have adapted to know its surroundings. And so that pretty much concludes the chapter. This chapter is different from other chapters because it is this chapter is about something we don't know more of what we know. So it's an exciting challenge for astronomers and scientists to figure out it's a challenge. So I just wanted to say thank you all for watching this video. Please like, subscribe, and share this video. Thank you, and bye!